Deze natuurlijk een nijneke. Poevereksnetten. Oh, gisla.
I am the chosen one. Somebody had to do it.
I am going to try and keep a balance between not wasting your time and also going slowly enough so you understand everything. It is 12:30 now. I have been working on this since 12:30 p.m. Not because it's hard, but because I've just been trying to debug my MacBook on Excel. So if you're also using a MacBook, I do feel sorry for you. What I'm going to do is we're going to start with the first case study, which is about the project selection, the engineers, the startup costs, and then the probability of success being thrown into the problem as something to be considered. So that's what I have on this sheet. Then what I'm going to do is I'm going to show you how to take this information that we got for the stock portfolio question, and then how to get your average returns, your covariances, and all that. So let's start with the question on the potential projects. Okay, so what I've done here is my decision variables are in pink. So that is the binary x sub I, so x sub 1, 2, 3, 4, 5, 6. This is a decision variable of how many engineers you assign to each project. So how many do we assign to the first, second, third, fourth, fifth, and sixth? And then when I say SC assigned here, that means startup costs assigned, or if you'd like to think about it, it's the startup capital that we assign. This in purple, these two things in purple, those are our linking constraints, and I will explain how that works. This is a column of alpha values, which is important for when we're calculating probability. These alpha values have all been given. So for example, the alpha value for project 1 is 0.8. The alpha value for project 4 is 0.1, and so on. So these have already been given to you. We also have a column for our net present value for each project, which is just something that you can take as a given, right? Because it's part of what you're trying to maximize. So what is different about this problem compared to the previous problem? A few things. So in the previous problem, we were just trying to maximize net present value. What we're now doing in this problem, because there's a probability of success we need to consider, we have to maximize the expected net present value. And so the expected net present value for any project is just the net present value of that project multiplied by the probability of success of that project. So obviously, for example, if the net present value of project 6 is 12 or 12 million, and it has a 50% chance of success, we would say that the expected net present value of that project is 6 million. So now what I'm going to do is just make sure that we're very clear about how to formulate the problem. And then I'll show you in Excel how to code everything that you need to code. So cool, we've got 6 potential projects. Very important is to understand this component, the probability of success, okay? So I will zoom, if I can zoom in a little bit. Okay, there we go. Let's just focus in here. So the probability of success is 1 minus, exponent is just e to the power, okay? 1 minus e to the power negative alpha, so a is alpha, 1 minus e to the power negative alpha times e sub I times s sub I. So whenever I say e sub I, s sub I, all that means is the I values for e and s, right? So engineers and startup costs is equivalent. So it would be negative alpha times the number of engineers allocated to, for example, the first project multiplied by the startup capital allocated to the first project. Or, negative alpha times the number of engineers allocated to the fifth project multiplied by the amount of startup capital allocated to the fifth project. So you're not multiplying, for example, the amount of engineers allocated to project 4 with the startup capital of project 6, okay? It's the amount of engineers in a given project multiplied by the startup capital of that same project. That is how you get your probability of success, okay? So I hope that's very, very clear. And I've also, in the Excel sheet that I'll publish, I've said it here. So alpha is given, E sub I is engineers assigned to the ith project, S sub I is startup costs assigned to the ith project. So what is our objective function? So I just want to make something very clear. You can also see, if you would like, what I've said here, the probability of success. You can also see it as this. So for example, let's call this P sub I is equal to this entire thing, right? Cool. So here, for example, when I say P sub 1, P1, P2, P3, P4, all these values are, as we're saying, maximize Z equals to the net present value multiplied by the probability of success of the first project, plus the net present value of the second project, or, the guaranteed net present value, if you want to call it that, multiplied by the probability of success of the second project, and so on and so on. Okay, so that's how I've written it out. Okay, now let's think of our constraints. We have about 2 constraints. So if you want to see it as, is that okay? So, okay, technically 3, right? Okay, so obviously you guys know that we have this binary decision variable, which is just, are we going to do the project at all or not, right? Which is just 1 or 0. So 0 if we don't do it, 1 if we do decide to do it. That's pretty obvious. So here we have our constraints. So the sum of the amount of engineers allocated to each project has to be less than 25, because we only have 25 engineers available, okay? And for our startup costs, the sum of the startup costs or startup capital allocated to each project has to be less than or equal to 4, because we only have 4 million in startup costs, in startup capital available. Okay, then we have our linking constraints. So they want you to write it out like this. You can also write it like this. So you can also say, I mean, it's I don't know why they're so particularly, oh my God. Okay, I don't know why I did that. I don't know why they clicked command instead of option. So you can also write it like this. So it's just E sub I is less than 25, X sub I. So for example, the amount of engineers allocated to the first project, assuming that that project is selected, so X sub 1 is equal to 1, also has to be, less than 25. So it's just an additional thing to say the sum of the amount of, the sum of engineers we allocate to all projects is less than 25. And for a given project, it can't be more than 25. But this also achieves something quite useful, which is that it ensures, if you think about it, let's say for the first project, if the decision variable, or the binary decision variable xi or x1 for the first project is equal to 0, then we have e1 minus 0 less than 0. So e1 less than or equal to 0, but we've also added the non-negativity constraint here. So if e1 is less than or equal to 0, but at the same time greater than or equal to 0, it is equal to 0. So this just ensures that whenever we have a project that we're not pursuing, we don't assign any engineers to it, right? Otherwise, engineers are going to rock up and there's no project, right? It's just a waste of money. And they take you to labor court for wasting their time. Or probably not. I mean, it's time off that they're getting paid for, so they enjoy it. But that just ensures that we don't allocate engineers to unselected projects, and the same logic applies. We do the exact thing here, except we have S sub I minus 4, X sub I less than or equal to 0, and the same non-negativity constraint. And I think something which I forgot to add here is that for all these have to be integer, right? So we can't have half an engineer, even if they're very, very short. It has to be a full person. Not that short people are less of a person or anything, but just so you're clear, it has to be integer. So now what you're probably here for is how we go about coding it. So I would just say, when you have these problems, first, before you do any coding, just do this part where you just, highlight, make sure everything is in the right order in a logical way that you can follow it. Just set it up first before you start with the coding. It makes your life a lot easier. Okay. How am I going to go about doing this? Okay, the easiest thing that you can code, the most important thing you have to get right in this problem is the probability of success. So I've actually written it down here. So in this over here, so this is just for me to round it to 2 decimal places, but the core thing you're going to say is you're going to say 1 minus, and this is important in capital letters, exp, in brackets, negative alpha. So alpha is our h5 over here. So negative h5 multiplied by d5. And now d5 is obviously our engineers assigned to the first project, multiplied by f5. That is our startup capital assigned to this project. And then this round is just to round it to 2 decimal places so that it aligns with what the memo has. Cool. And then once you've done it exactly like that, you can just, so I'll show you, for example. So these have all these values controlled for, but if I remove all of that, so let me just get rid of that. So I've got this. If I just drag this down like this, because I don't have a $sign, it'll just go 6, 7, 8, 9, 10, and that's fine. That's what we want in this specific context. So that's how you code the probability of success, and that's how you replicate it for all the projects. Okay, so we've got that down. And then the other easy thing that you can code is just your expected net present value. So forget about the rounding here. It's literally just multiply this with this. So here, for example, in this column, so you would say equal to product, right? So you would say J5, which is our probability of success for this project, multiplied by I5, which is our net present value for this project. That's all you have to do. And then again, I'll just prove to you that this works. So if I've got it in this format, no $signs, no nothing, if I drag it down, then I go to each one, J6, I6, J7, I7, and so on and so on and so on. So this entire part of the coding is now done. Okay, cool. Now, what are we going to do? Now, all we really need to do is our linking constraints and our totals. So totals is pretty trivial to do. So let's focus on the linking constraint, because this one is maybe slightly tricky. Okay. So I'll delete all of this and then I will do it from scratch. So you want to set up your linking constraint. Let's go and look at the formula for it. So the formula for a linking constraint is E sub I minus 25 times X sub I is less than 0. So what did I say? I said over here, this is equal to D5, right? Because that is our E sub I, that's our E1, okay? That's D5. So we're saying E sub I or E sub 1, right? Cool. Now what do we have to subtract? This is where you have to be careful, okay? We have to subtract 25 times X sub I. And so what I'm going to do here is I'm going to take this value. So this is our 25, as you can see. And then I'm just going to multiply it. And then I'll show you where you have to be careful with the mistake that I'm making. And then I'm going to multiply it by C5 because that is our XI. Okay, so that's great. Now, just note when you do this, make sure to go and put your $signs here. There we go. There we go. Okay, so put your $signs there, because what that does is now when I drag this down, you'll see that everything is replicated the way I want it. So we want our D5 and our C5. So we want D6, C6, cool. D7, C7, cool. But we want this to stay constant, and that's what the $sign is for. Cool, so we've coded our engineering linking constraint. Now let's code the startup cost linking constraint, and we do it in exactly the same way. So again, I'll just remove this and do it from scratch using this over here. This is our linking constraint. So what is it? It is S sub I minus 4 times X sub I, right? Less than 0, but that's when we get to our solver, we put that in our constraint. So let's say equal to, so this is F5. This is just our S sub I or S sub 1 in this instance. And then we subtract and we say, this time we're going to be smart. So we're going to say $sign F $sign 12. So what do we have here? This is our constraint, remember? Or this is just, or you can see it as a constraint, or just know that it's from the formula, it has to be 4. Okay, so, but it's, I would say, do it like this in this structure. It's very nice and symmetric. And then again, what do? We just say multiply this by x1. Okay, and then we just press enter. Okay, and now because I was smart this time and I put the dollar signs, when I take this and I go down with it, okay, all of these are zeros, obviously, because I don't have any values in here. But you'll see, okay, cool, F5, C5, F6, C6, F7, C7, F10, C10, great stuff. And I just highlighted this in yellow so you can see these are all the, this is, these are obviously our labels and these are our totals and our constraints. So this is really the actual values that we're working with. Just, that's why I put that there. Okay, so we have coded our linking constraint. We have coded our startup cost linking constraint. We have coded our probability of success, and we have coded our expected net present value. Now, all we need to do now is code our totals. So this is the easiest thing in the world to do. So we can delete all of this and then I'll do it from scratch. So I mean, how do you sum all of these values to give you the total for your engineers that you want to assign? Let's call it what you want to assign. Remember, we're constrained by 25. You just say equal to sum, choose sum, go from here, drag it down, and then if you want to be neat, put your parentheses there, and then you say equal to. Okay, and I think you can actually, usually you can drag this. I'm not sure if this will work. Does this work? Yeah, it does work. So it's summing up from E5 to E10, although we don't actually need that one. And then again, let's sum this up. Sum this up. And then be neat, put a parenthesis, boom. Okay, so we've got basically everything we need to solve the problem. Now we just need to plug things into Solver. But before we do that, let's just check if this thing works. So I'm just going to quickly go, just give me a second so I can find the memo. Okay, NLP case study 1. I'm just going to have a look at the final values that they got for the solver. And then we're going to plug that in, and then you can compare that to what they got. And then we can, I guess, sort of verify that we've done everything correctly. Because the issue with Solver is that on a MacBook, it just does some crazy stuff sometimes. Like I will assign something, for example, to be an integer. It just won't treat it as an integer. Or it just won't converge. It's just so many things that it just sometimes just doesn't like to do. Okay, so I think the final optimal value they got was this. So it was 1, 1, 1, 0, 1, 0, 0. Okay. And then the engineers assigned was 4, 5, 6, 0, 10, 0. Okay, so exactly meeting that constraint. And then one thing I couldn't figure out as well is how to constrain my decimal values. So maybe you guys can teach me how to do that in the comments. But what they got here for startup funds was 0.57, 0.81, 0.99, 0, and 1.64. Okay, and I believe a 0 here. Okay, so there's a slight bit of rounding. But if you just quickly go check just to verify, our expected net present value is equal to what you can see. I believe it's on page 35 of 36 of NLP case study 1.pdf on Amatuba under nonlinear programming weeks 8 to 9. I think it's the third PDF that you'll see. So nonlinear programming.pdf, convex, non-convex slides, and then NLP case study 1. Go to page 35, you will see this whole setup. So what we've done now is we've verified that all of our coding is perfectly correct. The only thing that's left now is our solver. So my solver does this weird thing when I click on it that I haven't managed to troubleshoot, where it basically exits out. But I will go to solver just for the sake of illustration. But just bear with me because it's just gonna do some weird stuff. So watch. Okay, if it even opens. Okay, there we go. Okay, so here's my solver. So what are we doing here? Sorry, this is really annoying. And it also doesn't let me actually like open this thing up a little bit. So we're just gonna have to do this a bit manually. So we have our objective function, K11, right? Because that's the sum of our expected net present value. And we have verified that everything has been coded correctly. And then what do we need to do? We need to change certain variable cells. So our decision variable xi, okay, goes from over here. Sorry, this thing is also lagging, like you see what I mean. This is just painful to work with. But if you check carefully here, oh my word. Okay, something went wrong, so I'm just gonna add in a cut there. But what do we have here for our variable cells that we're going to change? So it's going to be C5 to C10. I would recommend you code this manually. So everything that I have here, just like type it out. It just starts becoming a bit of a loss when you try and do the whole drag and select thing. So I would just say type it out, save yourself some sanity. So $C, $5, what is that? It's colon, right? No, is it semicolon, colon? I don't know. And then $C, $10. And then we do the same for D. That's from 5 to 10. That's our decision variable for engineers. And we do the same for F. That's our decision variable for startup capital. So cool. That's very important. Make sure you have that done and do it as precisely as you can. Then I've added in a couple of constraints here, which nothing should be too crazy. So I've made the X's binary over here, C5 to C10. What I've also said is that C5 to C10, so the XI values have to be less than the EI value. So it's basically to say it doesn't make sense for the decision variable to have a value of, for example, 1 and for the amount of engineers assigned to have a value of 0. Because technically, when it's working out all these probabilities and stuff, you can have a decent probability of success given the formula they give for probability of success, even if you don't assign an engineer. Well, you're not technically not. You're not actually supposed to get that, but it just sometimes goes wrong. So just add in a bunch of like just extra constraints because Solver can be a bit stupid sometimes. And then of course we've made sure I've made double sure that my decision variable is integer, even though you don't need to add that. But obviously we need to say that our engineer's decision variable is integer, D5 to D10, D5 to D10. And then, of course, that it's non-zero. And then I believe as well for our F decision variables, also non-zero. But then for our linking constraints, what we're going to say is, for example, for the linking constraint values of our startup costs, all of these have to be less than 0. And then for our linking constraints for the engineer, all of these have to be less than 0. Okay, so I'm just going to close this. I'm not actually going to run Solver because it just is a bit of a nightmare on this MacBook of mine. But everything here works. So just make sure you've got all your constraints. And so another important constraint I didn't mention is just your budget constraints, for example. So what you would just say here is that, D11 is less than D12 and that F11 is less than F12, because what we've coded here is the sum of engineers and we've just got our fixed constraint here in red. And what we've coded here is the sum of the startup capital sign, and then we've got our fixed constraint in 4 here. So that's very important. But if you do all of that, then you have a computer or a laptop that is actually designed to use Excel, then you should be fine. So I hope everything is clear. But beyond that, let's move to the next question. So we've got this question about the variances. So first of all, how do we get here? Okay, so if you just go to the Excel on Amatuba, I believe it is under nonlinear programming week 8 to 9, you will get an Excel sheet that looks like this. So all I did was I literally just did this and then I copied it and then I went to this sheet over here and I pasted it. So I did extend, so you can change the size of these things. So I did extend A little bit because that's where I put my labels. But if you copy and paste it exactly, so click on A1 when you do your pasting. So on Mac, for example, it's Command V. So I click on A1 when I do my pasting, I get that. Then you'll get this whole thing. So I just added some colors here. Very beautiful. And then we have all the values. So let's now see what we need to do. So the first thing you can do in this question, I'm not exactly sure what the question is actually. I just want to focus on getting you guys to be able to do it in Excel. And then you can just refer, the theory on this is pretty basic. So you can just go and refer to your theory. But here's what you do. So first of all, how do you get your average returns per stock fund or whatever, right? So for example, for this FINU whatever, I would use equals average B2 to B26, right? Because this is B2 and the end of it is B26. So it's basically telling Excel, if I delete this, I say equal to average, I select average, and then I go here to here, add my parenthesis, enter. Okay, oh, something has changed. But I think it has changed for the better, actually. I think I actually made a few mistakes in the way that I did these things. So we do the same logic here. So we say average. And then we go from here to here. And then we do that. We go like that. Okay. And we do the same thing here. Average. Start at the top. Drag it down. Parentheses, enter. Again, equal, choose average, and then select from the top, drag down, parentheses, enter. Okay, and I believe I don't know what mistake I made earlier, but these are actually the correct average returns. So that tells us the average return of each of these stock funds or whatever. That's your mean. Okay. Now let's get into the thing that you'll probably like getting stressed about when you're doing this. So what they want you to do is they want you to find or get a covariance matrix. Okay, so that is the matrix that I have over here and over here. And I'll explain what I did over here, even though that's not really important. So how do you get the covariance matrix? I mean, I think that's the more... Yeah, that's maybe one of the more frustrating parts of this question. So what I do here is I go to data analysis. Am I still recording? Yes. I go to data analysis. Okay, so I'm just going to scroll away. So a bunch of analysis tools that are very statistical. So let's go up. Okay, let's find covariance. So let's say I was over here. I go to covariance and I say, okay. Now they ask me for an input range. Okay, so what is my input range? My input range, if I just, if I restart this, is going to be from B2, right, until, wait, I think that's actually incorrect syntax. So we're learning as we're doing this. So I believe it's going to be from B2 until $E, what is this? E26. Okay, so that's going to be the input range. So we're just taking all of these values. So from B2 to E2 to E26. And then you choose group by columns because they are grouped by columns. So this is the one stock, this is the other, this is the other, this is the other. And then your output range. Okay, so that basically is just like, where do you want this thing to come? So, I mean, I can select it, I can put it anywhere. Let's say that I want it around here. So I want it to just where I have some space. I want the thing to come up there. So I'm going to say $N, I don't know, 7. Okay. And then I'm going to say, okay. Great. So now I've produced the covariance matrix. So what you'll notice is that they've left out these values. So for example, obviously the covariance between column 1 and 2 is the same as the covariance between column 2 and 1. So in order to get these values, you're just going to have to copy and paste. So put that one over there, put this one over there, and so on, right? And so then you'll get this full covariance matrix, okay? And then what you can do is, when you want to shift it around, you just do this, and then you cut it, or on MacBook it's Command X, and then let's say I want to move it to here. Then I just go blue, and then it goes there. But in this instance, here I chose this cell, I40, when I pasted it. What you would do here is you would choose A29 to paste it, just so that you can follow the memo they gave. But it's more important to understand what you're doing. So here we've got our covariance matrix. Then what we'll do is we'll just put our weights. So I think the given weights is 1/4 in each. Okay. And so what this is it's just a given example of a target. This is just the sum of our weights. So that'll be important later when we do it in Solver, but it's important that all of our weights sum to 1. And then what we have over here, or what I've done, is I've been very clever. Okay, so I've said here sum product B34 to E34. So what is that? So that's just the weights. So this is B34 until E34. And then some product that with B27 to E27. So that would be my average returns. I'm not so clear. I need to revise my theory a bit, but I'm pretty sure that's important for when you're doing these NLP problems. You're gonna have you want your weights multiplied with your averages. Okay, so that's what that little thingy does. So just get used to doing sum product. So I've just taken the weights, and then I've multiplied them by that. Right. So just for an example, how would you do that? You would go sum product. You would go like this. And then you would put your semicolon, and then you would go like this. Then you would put your parenthesis, and then there we go. You would get that value, negative 0.0013. Okay, then you can put the row here again. And then over here is where you do your matrix product. So I'm not exactly sure theoretically why you need this. It has to do with your variances and your covariances, all that kind of thing. So what I've done here is when I was working this out, I selected the entire thing, okay? So it says MMULT, so I believe that's matrix multiplication. And so what I've said is B38 to E38. So what is this? So B38 to E38 is our weights. So I've just put them there again. I guess you could have said B34 to E34 if you wanted. And then I've multiplied them. I've done matrix multiplication from B30 to E33. So from B30 to E33. Okay. And so what that is basically doing is it's just doing the necessary matrix multiplication to get these values. Not exactly sure why you need that again, theoretically, but this is just to focus on the Excel components. So how would you do this? So for example, if I wanted to re-get these values, so I would select that, and then I would say equal to, and then I'd say there we go, mult, and then I would say, if I can remember the values, I almost said B38, like that. And then, was it B30 to not E30 to E33. Yes, so you would select that entire thing, and then parentheses, and then and then you get the same values. Cool. So you're just you are just taking your weights, and you're kind of doing sort of a matrix multiplication with all your covariances, which is obviously important for when you're doing these things, these portfolio questions. And then for your portfolio variance, so what they tell you to do is they tell you to go matrix multiplication. They want you to go B39 to E39. So they want you to multiply basically these values, right? They want you to these values, right? But they're identical. They want you to multiply that, and then they're going to say transpose this. But what you can also just do is you can just rewrite it as a column, a vector. So, and I tested this, you get the same answer. Because you're just basically going, you're just performing matrix multiplication. And so what I did here to get my portfolio variance is I said, take the matrix product and do matrix multiplication. So B39 to E39, there we go. B39 to E39. And then I do my semicolon, and then I just went B41 to B44 instead of doing transpose B38 to E38. And then I got my portfolio variance. And then from there, you can just plug in the values for solver. It is given in the step-by-step thingy. I'll just quickly show it. You see it'll give me that thing. So what are we going to do to solve this? We're going to change the weights. So let me just move this around. So if you can see here, yes, like it, man. Yeah, it's very frustrating. But yeah, just trust me that we're going to change the weights, B38 to E38, which are over here. And which is the weights that we used when we were calculating like our portfolio variance and everything. And then that each of these weights is greater than or equal to 0. So we can't have a weight that's less than 0, non-negativity constraint. G34 is equal to 1. That's just going to be that our weights sum to 1. And then I believe G36 greater than C36. So our, what is this again? I think this is our return or something. So we want this value to be greater than 0.002. So that's the constraint. But I'm not going to plug this into solver because it's just going to destroy my laptop again. Yeah, whatever. Okay, so then we have that. So what have we done? So we know exactly how to do the NLP where we have these projects and where there's probability. We know that it's pretty simple. I would say the only bit of nuance here, honestly, is just your linking constraints. Making sure in solver you constrain the entirety of them to be less than 0. And making sure you don't have any bugs and that you code everything properly. And then just coding your probability of success. Okay, so I hope this has helped. If it has been beneficial, please like, comment, subscribe, all that stuff. Yeah, this took me a long time, not to figure out, but just because my MacBook is so useless. So yeah, good luck with the lab test, everyone. I will try my absolute best to upload the rest of NLP and simulation by the end of tomorrow. So good night.